Welcome back. Next up is Nicolas from Microchip, and he's going to tell everything around securing LoRaWAN devices using a secure enclave. Enjoy his talk.
Hello everyone and welcome. Thank you to the Things Conference for hosting us today. My name is Nicolas Demoulin. I'm a marketing manager within Microchip Secure Products Group. And today we're going to talk about LoRaWAN end-to-end security implementation from the device to the cloud, thanks to a great solution that we have implemented together with the Things industry, TTI. Now let's understand why implementing security. Historically, many reasons for that: revenue protection, brand protection, third-party ecosystem control. But also, since few years, in regards to the increased level of attack on IoT, we have seen popping up some standards and legislation on Internet of Things. Here are some examples. In Europe, we have the GDPR. We have also the ETSI EN 303645 standard, which is cybersecurity for consumer Internet of Things. We have the IEC 62443, which is security for industrial automation and control system, and so on. In UK, there is the Secure by Design, which is a code of practice for consumer IoT, similar to the EN 303645 in Europe. In California, another example is the SB 327 law, also known as the password law. Let's take the example of the ETSI 303645 standard from 2020. This standard specifies high-level security and data protection provisions for consumer IoT that are connected to a network infrastructure. For example, IoT gateways, alarm systems, smoke detectors, door locks, and so on. It specifies 13 cybersecurity provisions that can be implemented within the device or at higher level. As an example, point 4.2, which is requested to implement a mean to manage reports of vulnerability, does not directly concern the end device. The highlighted yellow point does concern the embedded device. There are some provisions about passwords, credentials, secure storage, secure communication, minimize risks. So let's look at the security basics and how to implement security features within the embedded device to answer to the standards. First of all, you need to implement 3 pillars. The first one is authentication. So you ensure that the thing is what is declared to be and has the right to authenticate and transmit on the network. Vice versa, the cloud needs to authenticate toward the device. So you guarantee the identity, you establish trust. And this is based on keys. The second pillar is integrity. You ensure that the content has not been manipulated, has not been altered. So you make sure that you are not facing man-in-the-middle attack. The concepts are genuineness or message checksum, and it's as well based on keys. The third pillar is confidentiality. So you protect the content from the prying eyes. The concepts are encryption, decryption, obfuscation of the contents, and it's based on keys for the 3 pillars. So, why are keys so important in a secure system? Well, it's all about the key. You should assess that a crypto system should be secure if everything about the system except the key is public knowledge. You should also assess that your enemies, the hackers, knows the system. So why are the keys so important? Well, because in the possession of the key, you can impersonate critical transaction. So now the question is how to protect the keys. Well, it's quite simple. Similarly to your credit card with smart card, similarly to your mobile phone with SIM card, you can protect the keys of your IoT system thanks to secure element. What's a secure element? It's a vault that protects the secrets. It's a companion device to any microcontroller, microprocessor on the market. Secrets are generated inside the vault during the manufacturing phase. And the secrets are leveraged thanks to the internal crypto engine of the secure element. So the secrets are never exposed and are handled by secure provisioning process through secure provisioning machine like HSM, hardware security module. So for a secure embedded system, we know we need to protect the keys. We know how to protect the keys with a secure element. Now the question is how to distribute the keys, the unique keys in each secure element in our fragmented and global markets through a complex distribution model and manufacturing model, and knowing that the goal is to reduce the exposure to third parties. That for small size customer, large size customer, for proof of concept project, for big projects. So now let's move to the interesting part of this presentation. How do we implement secure end-to-end solution within a LoRaWAN network together with Microchip and the things industry? First of all, you need to know that the LoRaWAN is built on a PS key, pre-shared key architecture due to the bandwidth limitation of the LoRaWAN network. The challenge of dealing with shared key or symmetric key is how to share them securely across a global fragmented marketplace. You need to share the key both in the node and in the server. Let's have a look at the LoRaWAN secure authentication scheme. You have the node, server, you have keys, application key, network key, and session keys that needs to be stored securely and exchanged in order to process to the secure authentication. So now how did we, the things industry and Microchip, solve the problem of key distribution and key protection? First of all, in the node, we are offering a secure element, the AT-ECC608B-TNG LoRa, that will securely store the credential of the LoRaWAN application. On the other side, the things industry is offering a joint server, which is a highly secure server that will also store the credential for network and application authentication. So now the question is, how do we securely distribute the keys from the server down to the node, to the secure element? For that, together with the things industry, we did perform a one-time secret exchange of the parent keys, the root keys. They are both stored securely in our HSM. Then, when we start the manufacturing of the secure element, we extract the unique serial number of the secure element that we upload in the HSM, and the HSM will derive the unique network key and application key from the serial number and the parent keys. Those unique network and application key will be securely stored in the AT-ECC608B secure element. In parallel, we will provide a signed manifest file to the customer, which contains the serial number of each secure element delivered. The customer will only have to upload this file into the things industry joint server, and the same process will happen. The HSM inside the joint server will derive the network key and application key based on the serial number and the parent key, and it will store them securely inside the HSM boundary. Let's look now at the different logistic flow and provisioning flow available. In order to support the proof of concept and start of production, Microchip can deliver pre-configured and pre-provisioned secure elements for LoRaWAN authentication as low as 10 units minimum order quantity. The devices are available pre-provisioned, pre-configured off the shelf. So you do not need to invest any time in implementing the security policy within the secure element. Everything is done already. If customer wants as well to implement additional security features like secure boot, they can transition to the TrustFlex flow, where the devices are also pre-configured and pre-provisioned for LoRaWAN network authentication with a minimum order quantity of 2,000 units. Then they have the capability as well to add their own secret for secure boot authentication. So, in addition to the end-to-end secure implementation of Microchip secure element and the Things Industry joint server, Microchip also offer pre-certified reference design, including module and system in package for a complete LoRaWAN application, microcontroller, RF, secure elements, and solution up to the joint server. We have an outstanding end-to-end onboarding lab for this effect that is available and that you can freely enroll through GitHub. So, what is the outcome of this end-to-end security implementation together with the Things Industry? 5 items to remember. The first one is the ease of use. Within the solution, you can perform authentication, rekeying, and secure boot over your LoRaWAN application. The keys comes pre-provisioned inside the secure element as well as inside the joint server. In addition, the Things Industry is offering 1 year of free service of the joint server. For sure, at the end of the year, you have the capability to extend the service together with TTI. It's based on a robust security in the backend. Both Microchip and the Things Industry HSM are FIPS 140-2 Level 3 certified. In terms of logistics, the claiming process is really simple. You just need to retrieve the manifest file and upload it on the joint server. On the end node on your application, the security is at the highest level. The ATE-CC608B is GIL High rated for secure key storage. So it means that you isolate the keys from the firmware, from the user, from the manufacturing operators, and from the equipment. Last but not least, the solution is fully flexible and fully scalable. You are network and application server agnostic. You are microcontroller and LoRa stack agnostic. You can perform rekeying, so it means transferring the control to a different joint server. And this is all based on a single part number that removes the hurdles of the manipulation of the unique shared keys. In addition to that, the ATE-CC608B TNG LoRa supports LoRaWAN 1.0 and 1.1 protocols. So, ease of use, secure backend, simple logistic, trusted node, and globally scalable. Thank you very much for attending to this session. So feel free to reach out to the Things Industry and Microchip if you want to learn more about how to secure your LoRaWAN embedded system, thanks to the secure element and the joint server. Feel free also to reach out to microchip.com/trustplatform to get more information about the provisioning services within Microchip. Thank you, stay safe, and secure your design.